Polynomial and rational inequalities. Now, before we talk about how to solve these or what they are, I first want to preface this by saying the concepts that we use for this, the way that we go through and we make these flags and these number lines and we find test points and we figure out if something is positive and negative and all those things that we're about to talk about, they have implications far beyond this in the math world. So for anybody who's going on to calculus or pre-calculus or beyond or whatnot, engineering majors, math majors, and the like, these processes that we do here, these types of things that we do here are going to follow you throughout. They have other uses, many other uses throughout math as you go through. So just wanted to preface with that. And so let's go through and talk about how do we solve these inequalities. Well, the first thing I want to do is get everything compared to zero. I want everything on one side of the inequality, less than, greater than, less than, equal to, greater than, equal to. There's four of them. And then decide if I'm looking for plus or minus, okay? So obviously if something is greater than zero, zero separates the positives and the negatives. If it's greater than zero, I want positive. If it's less than zero, I want negative. So I want to compare it to zero and so that gets everything on one side, compared it to zero, and decide if I'm looking for positive or negative. The second thing I want to do is factor, and by this I mean factor everything, both in the numerator and denominator. Now, if I don't have a denominator, I don't worry about it. I just factor it, okay? Because where I'm headed on finding zeros, as we did in the past with other things. So find zeros for both the numerator and denominator. Again, if you don't have a denominator, just find the zeros for the numerator, okay? I'm calling this the flags. I want to find the zeros for everything in the problem. Numerator, denominator, have it all factored. I mark all those flags on a number line as flags, then I shade them accordingly. So if I can equal a flag, I'll shade it in, sort of like a closed-in circle on a graph that you learned back in the day. And you know how you had to open and close. So then if you had an open circle, you didn't shade it or you didn't include it. So the same thing here. If I have just a less than or just a greater than, or if I'm in the denominator, because you can never equal the denominator, can never equal zero. And then I prefer to go ahead and write the intervals. And I'll talk about that a little bit. That's a little different and weird. It's one of the things I do a little differently than a lot of other people. I prefer to go ahead and write my intervals down at this point. And look, sometimes I forget, but I typically try to write them down at this point so that I have everything written down before I start writing my test points, which will be coming along in a minute. So brackets, right? Open or closed bracket will be used when we have a less than or equal to zero or a greater than or equal to zero, and the x values are from the numerator. The reason we don't use a bracket with the denominator is you can never equal zero in the bottom or denominator of a fraction. That makes it undefined. So all x values from the denominator, or if you have an inequality that is strictly less than zero or greater than zero, okay, we will use parentheses. Then we find test points. We choose values in each interval separated by the flags. And we're only checking when we plug the test points in, we plug it into our factored form. And we only check if it's positive or negative. We don't care if it's 9 or 99, but they're both positive. So we put a plus. We just care about positive or negative. The reason that I find my intervals and write them down up here is because that is before I get to my test points. When I start finding my test points, now I'm introducing new numbers that are arbitrary, by the way, to my problem, and sometimes I get confused, all right? So I'll be very particular about where I write my test points and where I write my endpoints for my flags and that kind of stuff. So I will only put flag numbers and intervals below the line, the number line, and test points and pluses and minuses above the line. And then we will eliminate. So we'll mark out the intervals that we don't want, and what's left is our answer. And then finally, that means we just write our answer down, okay? But we're going to write it in interval notation. Again, I went back and I wrote all my intervals up here. And whatever I don't mark out, those are the ones I keep. So what I'm going to do is give you some problems here. Solve each inequality, polynomial or rational. This one is a polynomial, right? There's no rational. There's no x's in the denominator down here, right? No denominator at all. So graph and place your final answer in interval notation. So if we look at this, is it compared to zero? Yep, that's done. Now, I need to figure out if I'm talking about positives or negatives, but let's see what all's done for me so far. I need to factor it, and guess what? That is also done. So I have those two things checked off over here. All right, but before I move on, this thing says x plus 1 times x minus 7, and this says less than or equal to. What kind of numbers are less than 0? That is correct, negative. I am looking for negatives here. Negative what you say, it doesn't matter. Anything that's less than 0 is negative. I also care about equal 0, but I take care of that with my flag. I'll shade my flags, okay, because I don't have any denominators here. So I will shade my flags like closed and open circles when you're graphing. All right, so here, my next thing says flags. Well, in my flags, I want to find my zeros. So I like to label, hey, flags over here, and then set each one of my factors equal to 0. Now, I know that I don't have equal 0 here, but for flags, we treat them like we're finding zeros. So we set them equal to 0, and that's both numerator and denominator. Now, when I write my denominators, I will put not equals just to remind myself, hey, you can't shade that flag, bud. Okay, just to make sure. So I'm going to solve this, subtract 1 from both sides. X equals -1 and plus 7 on both sides here, so x equals 7. So I, on this problem, found 2 flags. All right, you should find 2 flags. And my 2 flags are -1 and 7. And so part of finding my flags is to put them on a number line and label them with flags. All right, so let's come over here, and I'm going to make me a number line over here. Get me a number line, and I'm going to have 1 flag and 2 flags. All right, I have 2 flags here. And I'm going to put and it's important, you don't put them in the order they are over here that you found them in. You may find the biggest one first and the middle one last or whatever, if there's more than 1 or 3 or whatever. So, but you have to put them in order like they were on a number line. -1 is less than 7. You cannot do this. You cannot put 7 and -1. That makes no sense, right? You have to put them in the correct order. So -1 and, 7. All right? So, and look, the book I currently use right now does this for the flag. It has like a diamond shape at the top. That's too hard to draw. And plus, this flag makes me think of Mario. So anything that makes me think of Mario is a good. Okay? So, then I look back and I say, hey, I have equals. Because I want to determine, do I shade my flags or leave them open? Open flags mean I would use parentheses. Closed or shaded flags, I use brackets. So since there's an equals, I'm going to shade both my flags. I don't have any flags that deal with the bottom, the denominator. So all my flags here get shaded. If there was no equals there, I would not shade these flags. So here I'm shading these flags, shading them in nice and colorful here. Boom, shaded my flag. All right. So before I go on to my test points, before I do anything else, I like to go ahead and label my intervals. So I tell my students all the time, I'm extending my flagpoles deeper into the ground here, okay, going underground. And now I have an interval over here, an interval in the middle, and an interval to the right. So I have 3 intervals here, okay? My intervals, look, this arrow represents negative infinity. So we're going to start at negative infinity and go up to what number? -1. Then we're going to go from -1 to 7. And then we're going to go 7 out to this arrow. And that arrow is the right direction, which represents what? Infinity. We already know that infinity and negative infinity always get parentheses no matter what. You can never include them. They are directions. They are not numbers. You can never, ever, 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 ever include infinity. So they always get parentheses anytime you ever do interval notation. If you do interval notation with a bracket, just go ahead and get a pen out and count it off. All right? Because it won't be correct. So then -1, since I shaded my flag, I use a bracket on every -1 I have. I also shaded the 7 flag, so the same thing happens here, brackets on that. So now, this does not mean that these are my answers. I'm going to kind of darken my flags down here. That's not part of my interval. It's just separating them out. I have 3 possible answers to my problem here. I may get a combination of them. I may get all 3. I may get none of them. I don't know what's going to happen, but I have 3 possible answers here. So now I'm going to move on. So I have now done my flags. That's done. Now I want to move on to test points. So test points, there's 3 intervals. I need a test point here, here, and here. Now, here's the one kicker that I always see with the test points. Students, that you get on a test, they get nervous. Look, take a deep breath, calm yourself down, use your Jedi powers, okay? So calm yourself down and choose a test point in the correct interval. For instance, don't pick 0 right here, right? 0 is not less than -1. Maybe -4 works. You can pick -2. Some people are like, I want -2. Okay, pick -10, -100. Anything less than -1. In between -1 and 7, look, you can pick a lot of things. People say, oh, 1, 2, 3, 4. You can pick 1/2. If I can pick 0, I'm picking 0. 0 is the easiest thing to plug in the world. I'm plugging in 0 if I can. So if it's a negative number and a positive number for flags, you can always pick 0 between any negative and positive number. And then a number bigger than 7, it can be 8, 9, 10, 100, 57, 33, okay? I'm going to pick 10. It doesn't matter. You can pick 8. You can pick 7.1. I wouldn't, but you could. Okay? So I'm picking my test points. I want you to notice something. I wrote my flags below the line, and I wrote my test points above the line. Now, I started that years ago before I wrote these intervals down from the beginning, because when you go back to write your intervals down, people will go, oh, negative infinity to negative 4, because they look up here instead of down here. So be careful. That's why I wrote these down first before I ever wrote the test points down. That way I did not confuse any of my endpoints of intervals with what I chose, because you may have chosen negative 2, 0, and 8. That's fine. We should end up with the same answer, because remember, we're only looking for pluses or minuses. Okay, so with my test points, I also need to go in here and, okay, in my factored form, I have how many factors here? 2. So I'm going to put 2 factors in each one of my intervals here. I'm going to put 2 factors in each one of my intervals. Now I go back and plug my test points in. So in negative 4, I'm going to plug it into 2 places, 0 into 2 places, 10 into 2 places. If I had 6 factors, I'd plug negative 4 in 6 times. But here I only have 2. So I take negative 4 and I plug it in right here. So negative 4 plus 1, right, is what? Negative 3. But it doesn't matter if it's negative 3 or negative 33 or negative 333. It just matters that it's negative. So it's a negative number. So I know this looks like a TIE fighter from Star Wars. Okay. My first semester to ever teach, that's what left on my truck one day, was that looked like a TIE fighter. And it warmed my heart because I'm a huge Star Wars fan. All right. So then negative 4 plus 1 is negative 3. It's just negative. All we care is it's negative. And then if I take negative 4 minus 7, if I add 2 negative numbers together, I don't care what it is. The answer is what? Negative. It's negative 11, but 11's not important. Negative's important. So it's also negative. So why do I only care about the signs? Because if I'm multiplying, I know my rules for multiplying. What is my rule for multiplying 2 negative numbers? It's positive. That's right, it's positive. So then if I have a positive interval, then this whole interval, I'm just going to put a big plus sign there. If you want to darken it up, whatever, put a big plus. That's a big plus sign, okay? And maybe you don't want to cover up the stuff like I did. It's just, and sometimes I don't do that. Sometimes I just leave it that way right there, okay? With a bunch of little pluses across the top. That tells me this interval is positive. All right, then if I plug in 0, same thing. Take 0 and plug it in here and then here. So what is 0 plus 1? And I know y'all are saying 1, but it really only matters that it's a positive one, positive. What is 0 minus 7? Well, 0 minus 7 is going to be negative. So then now what is my rule when I multiply a positive number times a negative number? See, it doesn't matter what the value is, but positive times negative is negative. It's negative. So that entire interval is negative. So look, the reason we find the zeros, think about it. Zeros are x-intercepts. If a graph is bebopping along, here's the x-axis. If a graph is bebopping along up here and then it hits a 0, it either what? Bounces back up or goes through, and then bebops along, comes back. So everywhere on this side of the 0, it's always positive, and over here it's always negative till it gets to the next one, and always positive. So it does something like that the whole way through. It may not bounce back and forth every time, but between every 0, the whole function is positive or negative, or between any 2 zeros, I should say. All right. So, or from a 0 out to infinity. So then let's plug in 10. We're going to take 10 and do the same thing. Plug it into both these places right here. Okay. So what is 10 plus 1? If you said 8 plus 1, it didn't matter. 9 and 11, right? But they're both positive. That's what matters, is positive. And then what is 10 minus 7? It is also positive. And now what is our rule? If we multiply 2 positive numbers, we get a positive. So now my test point section is done. Okay? And the flags and the test points are where most of the work is. Sometimes getting an equal to 0 is tough, and then factoring it's even tougher. But flags and test points are where the bulk of the work is many of the times. But you can have a fair amount of work in the first 2 steps. Once you get past those 2 and get down to the bottom 2, it's really, really quick at this point. We already said we're looking for negatives, right? So if I'm looking for negatives, what do I do with this positive interval? I don't want it. So I mark it out. Notice I marked out all the way down here, so I marked that interval out. Right? I told you that was a potential answer. Well, I just eliminated that potential part of the answer. And then do I keep this one? Yep, keep that one. Don't mark it out. What about this one? Don't want it. It's not negative, so mark it out. So that means the only thing left is right here. So my answer in interval notation is negative 1, 7. Right here, right? So I did my eliminate, and then I wrote my answer down, right? and then that would be in my quote-unquote answer box, however you want to do it. If I have more than one interval, then I would union them together, or there are instances where, like, if two of these intervals were together, since I had brackets, I could combine them to one interval because the bracket's there to say I include the -1. If there's parentheses, you can never combine them. So we'll see some examples in here. I don't know if I have examples of every type, but the main idea here, again, the main idea for all of this right here is to make sure that we can do these steps, okay? Compare it to 0. Factor everything, top, bottom, everything. Numerator, denominator. Flags, right? Find the zeros of everything. Numerator, denominator, mark them. Do I shade the flag or not? Extend my flags deeper, put the intervals there. Do I have the right parentheses, brackets, all that parts of flags? Then test points, some number that's in each interval. Be sure you get a test point that's in the interval. Okay? The biggest mistake there is to pick one that is not in the correct interval. All right? So be sure to pick numbers in the correct interval. And then once you do that and figure out positives and negatives, then you eliminate what you don't want. The rest of it's your answer. All right? So let's go through this one. Is it compared to 0? Yep, it sure is, right? That means compared to 0 is what I mean, okay? It's got 0 on one side and an inequality there. In this case, that inequality is what? Greater. This is greater than 0. So what is greater than 0? Positive numbers. That means when I get down to my number line, I care about positives. I mean, negatives are okay, but on this problem, I don't want the negatives. I just want the positives, all right? The second step says what? Is it factored? Well, this doesn't look factored, right? I got a power bigger than 1, so let's try to factor it. So let's try to factor this. Let's see. This is 3 terms of the 1 in the front. I call this list method. Again, if you have trouble factoring, go see my list method video. It's one of the best ones I've done. All right? So I love the way I factor. 22 years of teaching, and that's why I do it that way. So then factors of 6 that subtract to give me 1. I'll come back to the plus in a minute, but factors of 6 that subtract to give me 1. You got 1 and 6, 2 and 3. 3 minus 2 is 1, so put in here a 3 and a 2, and it doesn't matter. You can put a 2 first and a 3. What matters is you get plus 3 or minus 3 correct, and plus 2 or minus 2 correct. That's what matters. So here, this says the signs are different, but I read it as bigger. The bigger number gets that sign. Well, which one's bigger? Bigger factor. 3 is bigger than 2, right? So it gets that first sign. The first sign here is plus, and so since they're different, the 2 gets a minus. And now I have it factored. And now it looks really remarkably like the one I just did. So the next thing I want to do is find my flags, right? After I get it factored, I want to find my flags. And on my flags, I disregard this part. Right now, I just do equal so I can find my flags. So I'm going to say x plus 3 equals 0 or x minus 2 equals 0. And then we're going to add 2 to both sides here. I don't like that plus did there. And then over here, we're going to subtract 3 from both sides. So those are my 2 flags. Again, I get 2 flags. Don't have any denominators to worry about. So I'm going to draw my number line over here for my flags. I'm going to say, okay, here's my number line. And flag and flag. Now, which one of my numbers is smaller this time? It's -3. That's right. A negative number is always smaller than a positive number. So -3 goes to the left and 2 goes to the right. You can't put 2 to the left of -3 on the number line. That doesn't make sense. It's got to be in the correct order. So then also part of my flags is, do I shade my flags or not? Well, look, is there an equals right here? Nope. So that means I don't shade either flag. So whenever I write down my intervals, I use what for those numbers or on those numbers? That's right, parentheses. I do not use brackets here anywhere. So again, this arrow represents negative infinity, and the one on the right represents infinity. So when I come down here, I'm going to extend the flags deeper in the ground. I'm going to bold them up a little bit so I don't get confused with other things. And I go from negative infinity to -3, from -3 to 2, and 2 to infinity. Parentheses always around infinity and negative infinity. Always the case. All right. And then -3 and 2 open flags, so they also get parentheses. So parentheses abound here. Parentheses everywhere. Again, those 3 answers are not necessarily my answer. Those 3 intervals, are not necessarily my answer. They are parts of my answer or some combination of them, right? Could be all three, could be none of them, could be two and not one, or one and not two, however. Right? So then, now I'm done with the flags part. I need to now come in here and do what? Find some test points. So what is a number less than negative 3? So be careful. You got to make sure you get something to the left of negative 3. So negative 87. I know that's kind of crazy, right? But I'm kind of crazy, right? So it can be negative 4. It can be negative 15, negative 10, whatever, negative 87. I don't know why I picked 87. I just did. And then between negative 3 and positive 2, again, if I can pick 0, I'm picking it. Sometimes you can't. If 0 is a flag, you can't pick 0. But here, 0 is not a flag, so guess what? I'm picking 0. And then a number bigger than 2. A number bigger than 2. 7. 7's my favorite number, so I typically pick it if I can. All right? So 7 is bigger than 2. You could have picked 3. You could have picked 87. You could have picked 100. If your favorite movie is 101 Dalmatians, you could pick 101 there. Okay? It doesn't matter as long as it's bigger than 2. If I look back, again, I have 1, 2 factors. All right? So I'm going to put 2 parentheses there. And all I care about is plus or minus. Remember. So with my test points here, plug in negative 87. So remember, I'm plugging that in for x on both these. So what is negative 87 plus 3? Well, look, if you do a negative and a positive, you subtract and take the sign of the larger one. Well, 87 is bigger than 3. So negative 87 plus 3 is a negative number. All right? Negative 87 minus 2. If I add 2 negative numbers together, guess what? I get a negative. See, it doesn't matter if it's 87 plus 2 or 8 plus 2 or whatever. Still negative. Add 2 negatives is negative. And what's my rule for multiplying 2 negatives? Positive. So this interval is a positive. And by the way, it doesn't always have to go plus first. It can be whatever. It can be, you have to check it each time because you don't know what's going to happen. 0, if I plug in 0 now to both these spots, what is 0 plus 3? 0 plus 3 is positive. What about 0 minus 2? That's negative, right? I'm plugging in 0 here and 0 here and seeing if it's plus or minus. I know it's 3 and negative 2, but it doesn't matter. It's a positive times a negative. What's my rule for multiplying a positive times a negative? It's negative, always. Any positive number times any negative number is always negative, period. And then finally I plug in 7. So then I have 7 plus 3 and 7 minus 2. 7 plus 3 is 10, is positive. And that's all that matters, positive, not 10. 7 minus 2, positive. What's my rule for positive times positive? Positive. I'm done with my test points now. I've got my pluses and minuses marked. And then now I eliminate. I wanted what? Positive, greater than. So positive, I do what? Keep it. Negative, what do? Get rid of that bad boy, right? That thing is gone. And then over here, positive, you keep it. So now my answer consists of negative infinity, comma, negative 3 in parentheses, and 2, comma, infinity in parentheses. It's both of those things. And I said the word and, but mathematically it's an or, okay? And how do I write that in interval notation? I use the little union. That's the U. That's not, this is the letter U that is not union. It is this. It is down and up. It does not have the tail of the kickstand right there, okay? So don't be putting the letter U up there. Put the union. Oh, and I did both the eliminate and then wrote my answer there in that color. They're done. Done. I'm done. Time for the next one, right? So again, it looks like a lot. It's a lot of steps I put there, but I wanted to write the steps out each time because mentally you need to have this process down pat, not just for these problems in whatever class you're taking now, but if you go on in math further past algebra, if that's where you're at now, then that's where my students are, is algebra right now. If you go past it, this is going to be used in every level of calculus, differential equations. It's going to be used in other things, in other classes. It's just a very good, useful thing to be able to figure out where something is positive and negative, okay? So here, 4x cubed minus x squared minus 14x is greater than or equal to 0. Is the whole thing compared to 0? Yep, it sure is, right? Compared to 0. So what am I looking for here? Greater than or equal to 0 is positive. I'm looking for pluses. Looking for pluses. The second thing it needs to be is factored. My powers are bigger than 1, and my pluses and minuses aren't in parentheses. You could say, well, they're all in 1, I know, but the power's bigger than 1, so try to factor it. I have 3 terms, but the very first thing I always do, I teach my students to recognize factoring by terms, the number of terms. But the very first thing, no matter how many terms you have, is GCF. That's the first way you learn to factor. It's the first thing you always look for. Here, guess what? Every term has what? An x, which means x to the lowest power, which happens to be x here. The lowest one is this one, 1. Right? I circled A there, the circle blank space because it's understood to be a 1. There's an x, so take an x out, and I'm left with 4x squared minus x minus 14, and that's still greater than or equal to 0. All right? But I'm not done factoring because now I still have this squared, or I potentially am not done factoring, I should say. If this won't factor, I may have to use the quadratic formula. Ooh, that'd be awful. I really hope that your teachers don't do that to you. But if they do, I mean, it's fair game because it is something you know, but I'm not going to do that here. This is going to factor. And if I look at this, it's 3 terms. I have 3 terms and not a 1 in the front and no GCF. That means this is what I call bottoms up. All right, many people call it that actually. I call it that because it's the best thing I've ever heard in my 2+ decades of teaching. So we're going to have the x out front, and then we're going to have the 2 parentheses here, greater than or equal to 0. But to do this, I'm going to come over here in a thought cloud. I'm going to come over here in a thought cloud because I love thought clouds. So I use a thought cloud here for 2 reasons. It's not equal to the problem, and I'm not done yet. Okay? So I'm going to come over here, and I'm going to take this 4 and multiply it by this 14. So x squared minus x minus, and look, I know 4 times 14 is not in your times tables you learned up in the 3rd grade or 4th grade or whenever you did it, okay, with the little flashcards. All right? So, or app, if you're younger, you used an app, I'm sure. All right? So here, look, 14 is 10 plus 4. 4 times 10 is 40. 4 times 4 is 16. So 10 and 16 is 56. All right? So x squared minus x minus 56. Now this becomes list method. It becomes very simple at this point compared to what it was before. This is x and 56. 1 and 56. 2 and 28. And you may already know what it is. 3 won't go into it. 4 and 7. 5, 6. Wait, not 4 and 7. I'm sorry. I just found it by 4 and 14, right? 5, 6, 7, and I was jumping the gun there. 7 and 8. So do any of those factors subtract to give me 1? Right? 7 and 8. So let's put in here 7 and 8. And the signs are different. I don't mean those. I know those are the same. That's not what I'm talking about. They're different because the only way to get a negative 56 is to have a plus and a minus or a minus and a plus. So the bigger number gets the first sign. Which one's bigger? 8. Oops, the first sign's negative. And then 7 gets a plus. And then I go back and say, okay, I need to divide. I multiplied this by 4. I need to divide both these by 4. So 7 over 4 won't simplify. This is the bottoms up part. I bring the 4 in front of the x, and that first parenthesis now becomes 4x plus 7. And by the way, you may have done yours backwards from mine, and I should say different. There's not a forward and backward here. You just may have done yours differently, and that's okay. Your 4x plus 7 could be second, okay, and not first. And then 8 over 4 becomes a 2. There's a 1 down here, so there's nothing to bring up. That just simply becomes x minus 2. So now I have that thing fully factored. I have the x out front, which don't forget about, the 4x plus 7 and the x minus 2. So now, finally, this thing is factored. And so that was a good bit of work, right? We had a GCF followed by bottoms up. That's a fair amount of work there. That's not just, let's just go do this real quickly, right? So then, what's next after factor? It's to find the what? The flags. The flags. So the way I find my flags, remember, is I set each one of my factors equal to 0. X equals 0, or 4x plus 7 equals 0, or x minus 2 equals 0. So x equals 0 is already solved. And then this one subtracts 7, so 4x is negative 7, and then divide by 4. So x equals negative 7/4, and over here add 2 to both sides. X equals 2. So I have my flags over here. Let's see, I'm going to come over here and got my number line. And this time I have 1, 2, 3 flags. Probably didn't give myself much room here, but 3 flags. What is my smallest flag? Well, the only negative number I have is negative 7/4. Then my next flag is 0, and my next flag is 2. I do have an equals here, and I don't have any fractions, so I shade all of my flags because equaling 0 is okay here, right? Equaling 0 helps me solve this thing. It says it's greater than 0 or it's equal to 0. So that's why we shade these flags, because the flags make it equal to 0. We just can't do that when they're in the denominator, but we don't have a fraction, so we don't have to worry about it. And then so we shade the flags, and then I'm going to come down here and extend this flagpoles deeper in the ground here, and I'm going to write my intervals down. Okay, so this is going to be negative infinity, because remember, this arrow represents negative infinity. Negative infinity up to negative 7/4, negative 7/4 to 0. And some of you are good enough, you can sit here and go, okay, I know bracket and parentheses already. 0 to 2, and then 2 up to infinity. Infinity and negative infinity always get parentheses. I don't care what's shaded or not shaded, or what's equal and not equal. I don't care any of that stuff. Never can you include those. And all my flags are shaded, so all my numbers get brackets. So all of them get brackets. So there's my flags. That part is done. Now I need to choose what? Test points. Choose me some test points. So a number out here, 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 and here. So it's real easy. Between 0 and 2 is 1. Bigger than 2, let's say 7. Between 0 and negative 7/4. So 4 goes into 7 one time with 3 left over. So that's between negative 1 and negative 2. So I know negative 1 I can use because it's negative 7/4 is to the left of negative 1. And then if you want to, if you have a fraction, you can, if that's the last thing over here, you can just do negative in the numerator. Negative 7 is going to be further to the left than negative 7/4. The over 4 brings it closer to 0, right? You're dividing 7 by it. So it makes it smaller and brings it back towards 0. So negative 7. Plus I get to use my favorite number again. All right. And then how many factors do I have? I got to be careful. I have this one and I have this one, but I also have the x out front. So I have 3 factors this time. 3 factors this time. So I need to put 3 parentheses here. Even though the x is not in parentheses, it's still a factor, because it's a GCF out front. And that's the thing people forget about sometimes, is that GCF out front. So now I'm going to plug negative 7 into here, here, and here, right? 3 places. So if I put negative 7 in right here, if I put negative 7 in for that x, that's what? Well, that's negative, right? Because you don't do anything with it. You just plug it in. It's negative. And then here, 4 times negative 7 plus 7. Well, look. If you want to figure out that it's negative 28 plus 7 is negative 21, that's okay. But 4 times negative 7 is a big negative number that's bigger than 7. So when you do a negative and a positive, the bigger number, you take that sign. So it's going to be negative. And then negative 7 minus 2. And again, 2 negatives, when you add them together, is negative. So now this is a little more complicated than the first 2 we did, because I'm multiplying 3 signs together. What's the rule for multiplying 2 negatives? That's a positive. And then times a negative is what? Negative. If you get 3 negatives, an odd number of negatives, y'all, every pair of negatives makes a positive. So an odd number of negatives is always negative. That interval there is negative. Okay? And then what about negative 1? I'm going to plug negative 1 in. So I'm going to put negative 1 here, multiply it, and negative 1 here. So if I plug negative 1 in right here, that's negative. 4 times negative 1 is negative 4. Negative 4 plus 7 is positive. So we got negative, positive, and then negative 1 minus 2, again, 2 negatives is negative. So it should be negative, positive, negative there. So I'm going to move those so I can do the next test point. Negative, we said, for plugging in negative 1 right here, okay? And then positive, and then negative. And then now we're going to plug in 1. So if I put in 1, 1, and 1, so plugging in 1 for x is positive. 4 times 1 is 4 plus 7 is positive. And then 1 minus 2 is negative. Oh, and I didn't do this. Let's go back in my negative 1 interval. 2 negatives multiplied together is positive times a positive. That whole interval is what? Positive. Okay? And then the next interval with 1 is 2 positives times a negative. Well, positive times positive is positive. Times a negative, that entire interval is negative. And then 7, I'm plugging 7 in. So if I put a 7 here, a 7 here, and a 7 here. Well, 7 is positive. 4 times 7 plus 7 is positive. And then 7 minus 2 is also positive. So every one of those intervals is positive. And so what happens if you multiply 3 positive numbers together? You get a positive. So my test points are done. So now, what was I looking for? Positive. And look, by the way, if you forget to do that at the beginning, that's okay. You can figure it out here. You go back and look to where you haven't compared to 0 and go, oh, it's greater than 0. I need, and I know this is or equal to, but I mean the greater than or less than part tells you plus or minus. So I want to get rid of my negative. I want to keep my positive. I want to get rid of this negative, and I want to keep this positive. So my interval notation here is going to be negative 7/4, comma 0. Both of those are brackets. And remember, we union it together, no tail or kickstand, all right? Up to what? Bracket with 2, comma infinity. And there's my interval notation of my final answer there. So that was my elimination part, and then of course that led directly into the answer. Here we go. Now we have a fraction. We have some rational ones here. So let's work through some of these and see what we can do with this. We're going to do the same thing. Is it compared to 0? Well, guess what? This one indeed is already compared to 0, right? It's greater than 0. So if it's greater than 0, I'm looking for pluses. And there's nothing magical about that circle. I'm just circling that going, hey, guess what? I'm looking for pluses. Looking for positives. It's greater than 0. And then, what about, is this thing factored? Well, guess what? All my pluses and minuses, look, this is a factored over factored. I want it in one overall term. And remember, a fraction, one factor over one factor is okay. If you have a fraction plus or minus something, now you got to do some work. But this one is factored. Both the numerator and denominator is written as one fraction. If you have multiple fractions, you got to do work. If you have multiple terms, you got to do work. But a fraction is all one term. If it's all one fraction, that's all one term. Just make sure the top, the numerator, the bottom, the denominator are both factors. So that's done for us. So now we're going to move on to our flags. So for our flags, we take everything in the numerator and denominator. X plus 5 is 0, or x minus 2, and when it's in the denominator, I go ahead and put a not equal to. That's just what I typically default to. I don't know if you're going to find that in the book anywhere. It's just something I do to remind me and say, hey, guess what? I cannot equal 2. Do not shade 2 if it's supposed to, if I have shaded flags, can't be 2. So I'm going to subtract 5 here on both sides. X equals negative 5, and over here, add 2, and x can't equal 2, but it's still a flag. So when I come over here and do my number line with my flags, flag and flag, which one is smaller? Negative 5, and which one's bigger? 2. Do I shade anything? Well, look, there's no equals here, so nothing gets shaded. Doesn't matter about top and bottom, numerator, denominator, all that stuff. It doesn't matter. Nothing gets shaded. So then everything I'm using here gets parentheses, right? Because we already know infinities get parentheses, positive and negative. So if I write down my intervals, it goes from negative infinity to negative 5, and then negative 5 to 2, and 2 out to infinity, and this is all parentheses. And so finally I'm done with my flags portion of this. But figuring out whether or not you shade those is very important, but because there's no equals here, none of that gets shaded. Now my test points, I need to pick a test point, pick them in the appropriate interval, okay? Don't pick negative 1 right here. That's not the right interval. Negative 5 has got to be less than that. So let's pick negative 10. And then something between negative 5 and positive 2, I'm going to pick 0. Something bigger than 2, I'm going to pick 3 this time. I know I've been picking 7. I like 7, but I'll pick 3 this time for those who want to pick 3. This one more. Okay? And then how many factors do I have? Well, look, I have 1 factor over 1 factor. So I actually like to write it that way, but you know what? The rules for division are the same for multiplication. And so I actually had a student in the past who was getting the concept of this really well, and he asked me, he said, Mr. Guest, can I just do this? Instead of writing it as a fraction, can I just do like we were doing multiply? It's the same rules. Sure, you can do that. So as long as you have the number of factors, it doesn't matter if you show them as multiplication or division, the rules are the same. If you divide 2 negatives, it's positive. If you multiply 2 negatives, it's positive. If you divide a positive by a negative and multiply a positive by a negative, they're both negative. The rules are the same. So with negative 10, I'm going to plug it in here and here. So what is negative 10 plus 5? Well, that's a negative number. It's a negative number. And negative 10 minus 2 is also negative. So what is a negative number divided by a negative number? It's positive. So that interval is positive. So now let's plug in 0. 0 plus 5 over 0 minus 2. That's positive over negative. And a positive divided by a negative is negative. All right, again, the key on this is I'm plugging the test point into every factor, and I only care if that factor is positive, plus, or minus negative. I don't care if it is negative 7 or negative 97. It's still negative. So then here with 3 plus 5 is 8. It's positive, and 3 minus 2 is also positive. It's 1, but it's positive. And if you divide two positives, you get a plus. And I'm not magic on 4 pluses or 5 pluses, but I'm just writing a bunch of pluses across there, right? And so that part, let me go back to that color. That part now, test points, is done. So now I'm ready to eliminate. I'm looking for pluses, so keep this one. Get rid of the minus and keep the last one, right? So I eliminated them, and then my answer is going to be what? Negative infinity to negative 5. Negative infinity to negative 5 with parentheses. It's just the same thing. I'm copying it over here. And then I have another interval, 2 to infinity. And I'm putting a union there between them. So there's the first rational inequality. All the rule, everything's the same. We're introducing the denominator of a fraction here. Same steps, that kind of stuff. Just remember, hey, if it makes the bottom 0, you cannot shade the flag. You have to use parentheses. So here, is it compared to 0? Yep. Less than or equal to 0 is compared to 0. So that's done, and we're looking for negatives. Is it factored? Well, look, I can't do anything with this part, 2x minus 7, but this down here is list method. I can do something with that. So let's go ahead and do that. Let's go ahead and factor this. So we're going to leave 2x minus 7 over, and we're going to try to make this into two parentheses with x and x. Less than or equal to 0 still. All right. Factors of 2 that subtract to give me 1. What are they? Well, 1 and 2 are the only factors, and they do work, right? 1 and 2. And the signs are different. The bigger number gets a plus. So the bigger number down here is 2. It gets a plus, and the 1 gets a minus. Now I have it factored. That part is done. And then on to my flags, and there's a good bit of work with flags, right? So let's find my flags, and we do that by setting everything in the top or the bottom equal to 0. So 2x minus 7 equals 0, or x minus 1. And again, I'm going to put not equal to 0, or, and if you want to put nor here, I guess this is not equal to nor. I'm going to put or. X plus 2 is not equal to 0. And I want to solve each one of these. So I'm going to add 7 to both sides. And that gives me 2x equals 7. I want to divide both sides by 2. And so x is 7 halves. And then I want to add 1 to both sides and get x equals 1. Or I'm sorry, not equal 1. And then subtract 2 over here and say x cannot be negative 2. So this one's going to be a little bit trickier because of the fraction here. Let me fix this fraction here. I don't like the way that looks. 7 halves here is this fraction. So when I come over here on my number line, I'm just going to come up here, I think, and make it across here. I got 1 flag, 2 flags, and 3 flags. And the smallest of my flags is negative 2. And then the other 2 are positive. 7 halves. 2 goes into 7 3 times at least. So that's bigger than 1. So then 7 halves is going to be my biggest flag. 1's the one in the middle. So the order matters. You got to get it in the correct order on a number line. Smallest to largest. And now I need to determine, do I shade my flags? Well, guess what? I got to equal. So I do shade flags, but I got to be careful. I cannot shade anything that makes the denominator, the bottom 0. And I reminded myself with not equals here, do not shade those 2 flags. But I do shade the 7 halves flag. So this one I shade. That flag I shade. The other ones I do not, because they make the denominator equal to 0. That was one of my notes, the red note on the first part of the video there when we were talking about the steps to solve it. Okay, so here, I'm going to extend this down a little further here and then write my intervals down. We're going to go from negative infinity to negative 2, negative 2 to 1, 1 to 7 halves, and 7 halves to infinity. Infinity and negative infinity get parentheses. In fact, so does negative 2 and 1. But when we get to 7/2, why do I use brackets? Because I shaded that, because that said equal, and because it was not in the denominator, right? So that gets the bracket there. So now I have my intervals written down. I'm done with my flags. Let's go with our test points now. A number less than negative 2, negative 4. A number between negative 2 and positive 1, 0. A number between 1 and 7/2. We just said that 2 goes into 7, 3 with something left over. So I'm going to do a 2 because that's in between 1 and 3 something. And then something bigger than 7/2. And again, I told you if you had a fraction, you can pick the numerator of the fraction if nothing else is past it, because that's going to be past it. You just may have if you have another flag in between, you got to be careful. So there, bigger than 3 point something. 3, right? 3 with a remainder of 1 is really 3.5. But 7 is bigger. It works. So how many factors do I have? Well, I have 1 in the top and 2 in the bottom, right? 1 in the numerator, 2 in the denominator. So I'm going to put 1 over 2 of them on each one of these, because every test point has to be plugged into every factor, right? Every test point has to be plugged into every factor. So if I plug my test points in, negative 4. What is 2 times negative 4 here? That's negative 8. Negative 8 minus 7. Well, that's a negative number. That's the wrong place to write it. That's a negative number. And then if I plug in negative 4, negative 4 minus 1, again, if I plug in negative 4 right there, a negative and a negative is positive when you add them together, so that's negative. Negative 4 plus 2 is also negative because 4 is bigger than 2. You add them together or subtract them, keep the sign a little larger when you add a positive and a negative. These two make a positive, and a negative divided by positive is negative, or again, you have 3 negatives, so the answer is negative. You plug in 0. 2 times 0 is 0. 0 minus 7 is negative. What is 0 minus 1? That's also negative. And what is 0 plus 2? That's not negative. That's positive, right? So here, these two negatives make a positive, and then divided by a positive is still what? Positive. Plug in 2. 2 times 2 is 4, right? 2 times 2 is 4. 4 minus 7 is what? Positive. And then 2 minus 1 is positive. That's 1 is positive. And then 2 plus 2 is also positive. So if you got all positives, then you got what? Uh-oh. What did I do wrong? Oh, 4 minus 7 is not positive, is it? So let me fix that. Some of y'all were screaming at the video here, right? Caught it. Not going to redo it. Caught it. When I did this, 2 times 2 is 4. What is 4 minus 7, right? 4 minus 7 is negative. This right here should have been negative, okay? That's where I went awry. So we fixed it. We fixed it. Negative. So a negative and then over a positive is negative. And then 7, 2 times 7 is 14 right here. 14 minus 7 is positive. That is positive this time. And then 7 minus 1 here is 6, which is positive. And then 7 plus 2 is 9, which is positive. So all positive is positive. So I just gave you a great example. And I'm choosing to leave it in here because I'm human just like you are, and I make mistakes. So if you find another mistake somewhere else, I'll re-record this video. So hopefully I don't make any more that I leave in there. Test points are done. And then eliminate. Eliminate. Well, I'm looking for negatives, right? So negative, we keep this interval here, right? We keep that one. We get rid of this one because it's pluses. We keep this one because it's negatives. And we get this plus we get rid of. So we get rid of this one. So my answers are going to be this thing and this thing right here, right? So negative infinity to negative 2 union 1 up to 7/2 with a bracket on that. So notice everything's parenthesis there except that 7/2 has a bracket. So we eliminated and we answered. Hope it just, I don't know if y'all saw the line that came up down here. That means it's going to mess up on me, but maybe we can get through it. Is this one compared to 0? Nope. So I cannot just go up here and check this off. Can't do that. Oops, can't do that because this is not 0. So how do I get it compared to 0? Well, I don't really want to move x's, so I'm going to subtract 2 from both sides. So x plus 1 over x plus 3 minus 2 is greater than or equal to 0 once I do that. Now it's compared to 0. It is compared to 0, but it's not factored, which is my next step. But it is compared to 0, so if I'm looking at greater than or equal to 0, I'm looking for pluses. So it is now compared to 0. I can check that off and say I'm looking for pluses. But when I factor it, I can't have this term and this term separate to have it factored. So to factor this thing, I'm going to have to do a fair amount of work here. I'm going to have to get a common denominator. Oh boy. But look, it's the same way. If you know how to do common denominators, it's the same way. Look, this 2 is really over 1. So my LCD, if I talk about this, my LCD is only x plus 3. There is no other denominator here. So what I'm going to do is x plus 1 over x plus 3 minus, and I'm going to say 2 times x plus 3 over what? X plus 3. Whenever there's, what am I missing here to get this? X plus 3. So I've got to multiply by that over itself. And so that's still greater than or equal to 0. And I'm going to say this is x plus 1, and I've got to be really careful here, okay? I got to be really careful here. I'm going to go ahead and show this step minus 2 times x plus 3 and put it all over my common denominator of x plus 3. The reason I don't skip this step, a lot of y'all will do this and say, oh, it's minus 2x plus 6. That's not right, y'all. The negative is with the 2, and that's going to be a minus 6 right there, okay? So, got to be careful. I take this negative 2 and distribute it, and I get x plus 1 minus 2x minus 6 over x plus 3. Still greater than or equal to 0. And then I combine my x's here, and then I combine my 1 and my negative 6. So x minus 2x is negative x, and 1 minus 6 is negative 5 over x plus 3, greater than or equal to 0. And you can stop there if you want to. Or you can say, hey, Mr. Guest, I don't like that negative x. I want to factor a negative out. That's fine too. Just don't forget you did that whenever you do your test points and how many factors you have in that kind of business. I'm going to leave it here because I think a lot of people will leave it here. But if you factor the negative out, that's also okay. There's different ways to do this. It's not just one way here. All right. So now we're going to say this thing is factored. And then after we factor it, we look for what? Our flags. So negative x minus 5 equals 0, or x plus 3 is not equal to 0. So, and again, I use not equal to because that's in the denominator. Here, I'm going to add x to both sides because that saves me a step. I mean, right, if I have negative x and add it to both sides, I end up with positive x equals, and I've got my answer. If I move the negative 5, I've got to then divide by negative 1. I get an extra step. But again, either way is fine. I just feel like this is more efficient. And that's part of the reason that I think we should teach math to everyone, is to be efficient, to problem solve, and to pay attention to detail. So those are the 3 big things I want you to take out of what I do. And then here, subtract 3 from both sides, x. And the reason I show this step here, I know it's maybe inefficient for some of you, but it's that detail. A lot of people will forget to change that sign. And look, if you're in school and taking tests and stuff, why not show that step? It's worth it. It's worth it to show that step. Make sure it's correct. So here on my number line, I have 2 flags. And which one is smaller this time? Negative 5 is smaller than negative 3. Again, doesn't matter what order it is up there. I happen to have it in that order, but it's smaller on the left, larger on the right. Do I shade any flags? Well, I have a greater than or equal to here, so I do shade flags, but I got to be careful. I can't shade the negative 3 because it's in the denominator. So I shade the negative 5. Shade the negative 5. And then I'm going to extend my flagpole deeper in the ground here and write my intervals. Negative infinity to negative 5, negative 5 to negative 3, and negative 3 to infinity. Infinity and negative infinity, always parentheses. Negative 5 this time gets bracket because I shaded it. Negative 3 gets parentheses because it's not shaded. Right, the shading leads me there. All right, I'm done with my flags now. Now I want to do some test points, right? I want to try me out some test points here. So something here. So less than negative 5, negative 7. Between negative 5 and negative 3, well, the only integer there is negative 4. Now you can pick something else, negative 3.9, negative 3.5. I'd pick negative 4. And then something bigger than negative 3 If I can pick 0, I'm picking it. I don't like the way that looks. That didn't see it earlier. That's -7. All right. So the pen kept going there. -7. All right. So I have 2 factors in my factored form down here. 2 factors. If you factor the negative out, you'll have 3 actually. So factor over factor for each one of these, and then start plugging stuff in. So if I plug a -7 in here, I got to be careful. What is a negative of a -7? That's 7 minus 5, which is positive. All right, it's positive. So this is a plus. And then -7 plus 3. Well, 7's bigger, so that's a negative number. Positive over negative is negative. And then -4. A negative of -4 is 4 minus 5 is negative. And then -4, if I plug it in here, -4 minus plus 3 is negative. A negative over a negative is positive. And then if I plug in 0, 0 minus 5 is negative, and 0 plus 3 is positive. So that gives me a negative over a positive, which is negative. And that finishes up my test points. And I was looking for positive, so I get rid of my negative. I keep this positive here, and then I get rid of this negative right here. And I am simply left with -5 with a bracket, comma -3 with a parenthesis. And that is all I'm left with there. So I eliminated what I didn't need and found my answer. So hopefully now we've done several of these. You're starting to get comfortable with them. You got to remember not to shade flags that make the bottom, the denominator 0. That one was pretty tough because you had to go set it equal to 0. And I think I have one more here for us to do. Yep. Is it compared to 0? Yep. And I'm looking for greater than 0, which means positive. Also, this thing is factored, right? I got this factored and this factored and this factored. Even though it's to a square, that's okay. It's still factored. So the factoring part's already done, so I can move straight into the flags. I can move straight into the flags here. We're going to say x plus 1 is 0, x minus 8 is 0, or, and look, do I care about the squared here? I mean, it does matter. Don't get me wrong, it does matter, but when I'm finding zeros, that power does not matter, okay? And I told you it was like finding the zeros of the numerator and denominator. So the only way to get x minus 4 squared equaling 0 is if x minus 4 equals 0. You can't square any other number and get 0 but 0. So subtract 1. Oh, and I need to put not equal to because that's in the denominator. So subtract 1 here from both. You get x is -1. You add 8 and get x is 8. And then over here you add 4 and you get x is what? 4. And come over here on my number line. Let's see. Let's make a number line here somewhere in some space. And I have how many flags on it? Looks like I have 3 flags. What's the smallest of my 3 flags? -1 and then 4 and then 8. That's a little easier than this, whatever one we had with fractions a while ago, 7/4 or something. I don't remember what it was. Okay. Do I shade any of my flags? Well, there's a denominator. We definitely don't shade it, but look, there's no equals down here, right? If there's an equals, I would. There's no equals, so we don't shade any of these flags, which means what do we use throughout our problem? That's correct. Parentheses. So negative infinity, comma, -1, both with parentheses. -1 to 4, both with parentheses. Parentheses 4, to 8 with parentheses, and then parentheses 8 to infinity. Make my comma not quite so big there. So again, those are my potential answers, not necessarily the answers. And then I have how many factors? I have 2 in the numerator, 2 in the top, and 1 in the bottom, in the denominator. So 2 factors over 1 factor. And also, there's one other thing I can note here. In my denominator, well, we'll talk about it as we plug it in. So, and I skipped over that. I was through with my flags. I'm sorry. Let me go back and fix that. I'm through with my flags. I'm on to test points. Through with flags. Let's move on into test points. So that's where I would do these two here. And my OCD wouldn't let me leave them the same color. So I'm plugging in some test points. I need to choose those. I didn't choose them yet. Something less than -1. How about -3? Something between -1 and +4, 0. Between 4 and 8. Okay, I want to pick 7, but I'll pick 5. And bigger than 8, I'll go with 10. You can pick 9 or 100 or 8.1. If I plug -3, I'm going to plug it in here, here, and here. Okay? So -3 plus 1 is negative. Right? -3 plus 1 is -2. And -3 minus 8, 2 negatives gives you a negative. And then -3 minus 4 is negative, but then you square it. What is a negative number squared? Positive. In fact, in the real numbers, what is anything squared? Positive. If you don't see this, don't do it. But I want you to see, hey, if I'm squaring this, it doesn't matter what I plug in there. It's always going to be what? Positive. We can talk through it, but that's if you square it, if it's any even power, it's going to be a positive every time. So plug in 0. What is 0 plus 1? It's positive. 0 minus 8 is negative. So we got a positive and a negative. And if I plug 0 in here, you get -4, but then you square it, that's positive. Already got a positive right there. And then 5, plug in 5. 5 plus 1 right here is 6, which is positive. 5 minus 8 is -3. It's negative. So you got positive and negative. And then 5 minus 4 is 1. It's positive. And you square a positive, it's still positive. Got it written there. We already talked about squaring it. It's going to be positive. And then 10. 10 plus 1 is positive. 10 minus 8 is positive. And then 10 minus 4 is 6, which is positive. But when you square it, it's still positive. So what do my rules say? I didn't do that yet. What is a negative times a negative here? It's a positive, and a positive divided by a positive is positive. And then positive times a negative is negative. Negative over positive is what? Negative. And then here again, that's negative over positive is negative. Uh-oh. That didn't bounce back and forth, and that's okay. It's not going to when the multiplicity is even. We talked about that, right? Multiplicity. There's a video for that. All right. And then everything's positive. All positive. Okay? So now I'm done with my test points. Now it's time to mark things out that I don't want and write down my answer. I wanted positives. Keep this one. Get rid of the minuses. This one and this one. Now on this one, if I had kept these two intervals together, since it's an open flag, I could not have combined them. Okay, I talked about that, mentioned it earlier about combining them possibly with brackets. There's no brackets here. You would not have combined them. So then my final answer here is going to be what? It's going to be -infinity to -1 union 8 out to infinity. And there is our final answer. So I eliminated, I answered it in this color, and let me check it off in the color I eliminated it in. All right. So I hope this video helps you. And again, this information extends itself well beyond algebra into various